Azure at scale, why tooling is the architectural lie. Most organizations believe Azure scale is a tooling problem. If they buy the right CI/CD suite, the right monitoring stack, the right IAC framework, the chaos will stop. They are wrong. Scale fails as drift, queues, and just this once exceptions that turn into permanent backchannels. Tooling doesn't prevent entropy, it accelerates it. In this episode, you'll get an operating model that survives growth, audits, and outages because it makes intent enforceable. Azure Landing Zones are the early anchor, the place where org design becomes enforceable. First, define the failure mode. The enterprise scale trap, velocity turns into drag. Here's the pattern. Cloud starts as velocity. Then the bill shows up, then the audit shows up, then the incident shows up, and suddenly your cloud transformation looks like a distributed argument about who owns what. Most enterprises begin with the migration mindset. Lift, shift, declare victory. Projects finish, operations begin, entropy starts, because a cloud estate is not a set of completed projects. It's a long-lived system that accumulates exceptions, special cases, and inconsistent execution paths. Every shortcut becomes a precedent, every precedent becomes a policy gap, and every gap becomes a future incident review with your name on it. If you're a CIO, this is the part you usually miss. Cloud debt is not technical debt. It's decision debt. It's the backlog of unresolved ownership questions your organization postponed while shipping features. Now, the most common phrase that signals you've entered the trap is, every team does DevOps differently. That sounds like empowerment. In reality, it's compound interest on complexity. One team builds pipelines in Azure DevOps, another uses GitHub Actions, a third uses whatever the last contractor liked. Everyone pins Terraform versions differently. Secrets land in different places. Logging is optional. Tagging is a suggestion. And you still tell yourself it's fine because they're autonomous. They're not autonomous, they're ungoverned. And ungoverned systems don't scale, they sprawl. This is where cloud sprawl becomes the comfortable diagnosis. It's not wrong, but it's not specific enough to fix anything. Sprawl is a symptom. The disease is that you have YAML everywhere and intent nowhere. Your controls exist as documents and meetings instead of enforced defaults. Your standards are guidance that teams root around under delivery pressure. Your platform team becomes a help desk because governance lives in humans. Now here's where most organizations mess up. They respond to the symptoms with centralization by incident response. Something breaks, security gets nervous, finance gets loud. So the default move is to pull control back to a central team. They take ownership of networking, identity, subscriptions, pipelines, approvals, maybe even deployments. It feels safe. It is not. That move creates queues. Queues create bypasses. Bypasses create shadow standards. Shadow standards create drift. And drift is the mechanism by which your policies quietly stop matching reality. If you run a platform team, this is the trap you'll recognize. You didn't choose to become a ticket factory. The system designed you into one. Every ambiguous decision right turns into a ticket. Every ticket becomes a wait time. Every wait time becomes an exception request. And exceptions are entropy generators. If you're a cloud architect, this is the uncomfortable truth. Most architecture at enterprise scale is just org chart problems with a YAML file attached. You can draw the best hub and spoke diagram on the planet. If nobody has clear authority to enforce network attachment at subscription creation, your diagram is decorative. You can write a policy initiative that looks beautiful. If exception handling is favors and side deals, your policy is aspirational. You can publish a golden Terraform module. If teams can fork it without consequence, you've just created hundreds of permanent snowflakes. Azure behaves like a distributed decision engine. Every team interaction, every approval, every role assignment, every policy exception is part of the authorization graph that shapes what happens next. That means your operating model isn't a PowerPoint. It's the set of decision pathways the organization actually uses when under pressure. Over time, those pathways accumulate. Missing policies create obvious gaps. Drifting policies create ambiguity. Exceptions create alternate routes, and alternate routes become the real system. This clicked for me when I watched the same movie repeat. Organizations spend months evaluating tools, then deploy them, then celebrate platform modernization. 6 months later, they're slower than before. Not because the tools are bad, but because tools made it easier for every team to express its own interpretation of how we do cloud. At small scale, that looks like agility. At enterprise scale, it's fragmentation. So the foundational misunderstanding is this. An operating model is not a tool chain. It's a decision system. Who decides, who builds, who runs, who pays, and how exceptions work when the system says no. Before we argue about pipelines, Terraform, or portals, you need that definition, because everything else inherits it. What an operating model actually means. So let's define it cleanly, because most orgs use operating model as a polite synonym for governance meetings. An operating model is the decision system for cloud. Who has authority to make which decisions, how those decisions get implemented, and how they get funded and audited once they're real? Not once, continuously. Because cloud is not a migration milestone. Cloud is a long-lived product capability your organization owns forever, whether you admit it or not. If you remember nothing else from this section, remember this. The operating model is the control plane for human behavior. It's how you enforce assumptions at scale without needing heroics, tribal knowledge, or constant escalation. And yes, that means it has to include finance and risk, because in cloud, those aren't stakeholders. They are runtime dependencies. Most organizations try to solve this with standardization. They publish standards, naming standards, tagging standards, pipeline standards, logging standards. Then they act surprised when none of it sticks. Because the thing most people miss is that standardization without enforceability is just documentation. In reality, you need constraints, minimum viable constraints, not maximum control. If you're a CIO or CTO, here's the uncomfortable implication. You are not designing cloud governance. You are designing delegation and funding. You're deciding what gets centralized as shared capability, what gets delegated to product teams, and what gets measured so you can tell if the system is working. If you don't do that explicitly, the organization will still make those choices. It'll just do it in the worst possible way, during incidents. Now, the simplest model that actually works is to treat cloud as a product operating model with decision rights. Cloud platforms don't scale because engineers are talented. They scale because the organization converges on consistent pathways, predictable ways to create environments, predictable controls, predictable exceptions, predictable accountabilities. So what are the moving parts? First, decision rights. Who owns the platform baseline and who owns workload outcomes? That boundary needs to be written down like adults, because otherwise your autonomy turns into someone else will fix it. Second, delivery system. This is the part everyone obsesses over because it has tools. But delivery is just the mechanism by which change enters production. If delivery isn't aligned with governance, teams will route around governance every time. Third, shared services. Things that must be consistent to be safe and efficient at scale. Identity integration, network connectivity, logging and monitoring foundations, policy enforcement, and often subscription provisioning. Shared services are not about control, they're about reducing duplication and reducing blast radius. Fourth, guardrails. This is where guardrails, not gates, actually matters. Gates stop the business. Guardrails constrain the shape of change so it remains safe. Guardrails need to be automated, visible, and measurable. If your guardrails require humans to be awake and in a good mood, you don't have guardrails, you have a social process. Fifth, accountability. Who is on call? Who owns the SLOs? Who owns cost? Who owns policy compliance remediation? And critically, who has the authority to trade off speed versus risk? If you can't answer those questions quickly, you don't have accountability. You have diffusion. Now let's anchor this in Azure early so it doesn't stay abstract. Azure Landing Zones are where this operating model becomes enforceable. Not because ALZ is magic, because ALZ is the first place you can encode organizational boundaries into management groups, subscription structure, identity patterns, network attachment, and policy baselines. It is literally org design expressed as an enforceable control plane. If you run a platform team, the point of ALZ isn't to deploy the landing zone. That's day one theater. The point is to operate it as a product, versioned changes, measurable adoption, and explicit exception pathways. If you're an architect, this is the pivot. Stop treating operating model as culture and start treating it as architecture. Culture is what happens when architecture fails to constrain behavior. Next, we'll make this measurable, because if you can't measure it, you can't defend it in an audit or a budget review. The three metrics that expose the lie. Tooling debates stay comfortable because they're qualitative. Everyone can argue forever about best CI/CD or the right ISC language, and nobody has to admit their operating model is broken. Metrics don't allow that escape. If you measure the right three things, the lie shows up immediately. You don't have a platform problem, you have a decision system problem. And the reason this works is simple. These metrics trace the actual pathways teams use under pressure, not the ones you described in a steering committee. Here are the three. First, lead time. Not are we shipping, but how long it takes for a change to go from committed to running in production. DORA popularized this metric for a reason. It exposes friction that teams stop noticing because they're used to it. If your lead time is long, it's rarely because engineers are slow. It's because your delivery system is full of hidden gates, manual approvals, bespoke pipelines, inconsistent environments, security reviews that happen at the end, and platform dependencies that require tickets. If you're a CIO, this is the implication. Lead time is the business cost of your internal bureaucracy expressed as calendar time. You can call it governance. The business experiences it as delay. If you run a platform team, lead time is also a mirror. Every time you demand alignment through bespoke reviews, you add minutes that become days at scale. Second, time to first environment. This is the metric almost nobody measures, which is why the ticket factory survives. It's the time from we need a new workload environment to we have a usable governed place to deploy. In Azure terms, it's the time from request to an appropriately placed subscription with baseline RBAC, network attachment, logging, and policy already in effect. This metric is ruthless because it captures platform friction at the starting line. You can have elite engineering teams and still lose if it takes 3 weeks to get a subscription and a network connection. And here's the uncomfortable truth. Long time to first environment creates shadow infrastructure. People don't wait. They root around. They use old subscriptions. They reuse test environments for production-like work. They deploy into places they can access. They create temporary exceptions. Those exceptions don't expire on their own. If you're an architect, this is where ALZ stops being a reference diagram and becomes a real operating model anchor. Subscription vending is not a convenience feature. It is the mechanism that makes autonomy real while keeping governance intact. Third, policy compliance rate. Not we have policies, but how many resources are actually compliant with your critical baseline and how quickly non-compliance gets remediated. This metric is how you distinguish governance theater from intent enforcement. Azure policy and initiatives can measure this for you, but they can't make you care. The platform will happily show you a red compliance dashboard for months while everyone pretends it's fine. If you're a CIO, this is the implication. Policy compliance rate is audit readiness expressed as a number. It's also incident likelihood. Low compliance is not a report, it is a prediction. If you run a platform team, compliance rate is also how you prove you're not just doing tickets. You're maintaining a baseline that stays true over time. Now, notice what these 3 metrics have in common. They are boundary metrics. They measure the health of the interfaces between teams, platform and product, security and delivery, finance and engineering. They don't care what tool you use. They care whether the system produces predictable outcomes. And once you instrument these, you'll see the real failure mode. The organization optimizes locally. Teams optimize for shipping. Security optimizes for blocking risk. Finance optimizes for budget control. Platform optimizes for throughput. Everyone wins locally. The enterprise loses globally. That's why these metrics work. They force a single view of reality. Next, we turn these numbers into structure, because metrics without ownership boundaries are just dashboard art. Decision rights, platform versus product written down like adults. So here's the part everyone avoids because it forces uncomfortable clarity. Decision rights. Not who helps, not who reviews, not who has an opinion, who actually owns the outcome and therefore absorbs the consequences when it fails. If you don't write this down, Azure will still run. People will still deploy. Policies will still exist somewhere. But the system will behave like a rumor network. Whichever team answers fastest becomes the owner, and whichever team escalates hardest gets the exception. That is not governance. That is conditional chaos. The clean boundary is platform versus product. Platform teams own the baselines, identity integration, network connectivity patterns, policy and management group structure, logging and monitoring foundations, and the mechanisms that create governed space. The platform owns the paved road. The platform does not own every car. Product teams own workload outcomes, workload configuration inside the boundary, their SLOs, their on-call, their data handling decisions, and their unit economics. If they want autonomy, they take the cost of autonomy. That's the trade. If you're a CIO, the implication is simple. You are buying risk distribution. When you centralize cloud, you centralize risk and queues. When you decentralize cloud, you decentralize risk and inconsistency. Decision rights are how you choose which failure mode you're willing to live with. If you run a platform team, this is where you usually fail by being too helpful. You accept responsibility for things you can't sustainably operate. You say yes to bespoke networking, bespoke identity exceptions, bespoke pipelines. You become the dependency that every team must wait for. Then everyone blames you for being slow. That's not a staffing problem. That's an ownership design problem. So what does written down like adults actually look like? It's a simple matrix. Rows are decisions, columns are roles. You don't need a fancy RACI. You need platform decides or product decides plus the enforcement mechanism. For example, management group structure and subscription placement, platform decides. Enforced by subscription vending and management group policy inheritance. Identity and access baseline, platform decides. Enforced by role design, PM patterns and least privilege defaults. Network attachment and egress model, platform decides. Enforced by network architecture that workloads attach to by default, not by ticket. Policy baseline, platform decides. Enforced by initiatives applied at management group scope with documented exception pathways. Observability baseline, platform decides. Enforced by diagnostic settings, policies, and required telemetry patterns. Then, product-side decisions. Workload resource selection inside allowed regions and SQs. Product decides within policy constraints. SLOs and error budgets. Product decides and owns the page when they miss them. Deployment cadence and change management inside the pipeline guardrails. Product decides and owns the blast radius. Cost targets. Product decides, and finance expects an answer that isn't Azure is expensive. Now here's where most people mess up. They treat exceptions as shameful. They treat exceptions as favors. They treat exceptions as a side channel. Exceptions are not shameful. They are inevitable. But unmanaged exceptions are entropy generators. They convert a deterministic security model into a probabilistic one, because every exception creates a special rule someone will forget to revisit. So you need an exception pathway that is designed, not improvised. That means every exception has an owner, a reason, a compensating control, and an expiration. If it can't expire, it isn't an exception. It's your new baseline, and you should admit that. In Azure terms, this is where ALZ stops being a deployment and becomes a product. You don't just apply policies. You run policies, you measure compliance, you review exceptions, you retire old deviations, and you need an escalation path that doesn't depend on heroics. Product teams should know exactly what happens when a policy blocks them, where they request deviation, how quickly they get an answer, and what no looks like when the risk isn't worth it. Because when no is ambiguous, teams don't stop. They root around. Once ownership is explicit, something weird happens. Tickets stop being a workflow, they become a symptom. And symptoms are fixable. Next, we turn this into team design that survives scale, because decision rights without team interfaces still collapses back into tickets. Team design that survives scale, platform teams as product teams. Now the part that separates organizations that scale from organizations that keep hiring. Team design. Because once you've written down decision rights, you still have to build a system that makes those decisions executable without constant negotiation. And the platform team is the pressure point. If you build it wrong, it becomes the cue that throttles the entire enterprise. So here's the reframe. A platform team is not an infrastructure team that happens to use Azure. It is a product team that happens to ship constraints. That distinction matters. If your platform team measures success by tickets closed or projects delivered, you've already lost. Those are throughput metrics for a help desk. A platform exists to reduce cognitive load for product teams, to make the paved road so easy and so safe that most teams never need to think about the underlying platform at all. If you run a platform team, your backlog shouldn't be more features. Your backlog should be developer pain. Where are people getting stuck? What forces exceptions? What takes days that should take minutes? What makes teams reinvent the same plumbing? And which parts of the platform are so ambiguous that people keep opening tickets just to ask what the policy even means? If you're a CIO, this is the implication. You don't fund a platform team to build infrastructure. You fund it to build leverage. Every self-service pathway they create removes future headcount demand in operations, security reviews, and cloud enablement committees. Now, team topology matters here because platform teams don't scale by centralizing everything. They scale by having clean interfaces. The core pattern is simple. Stream-aligned teams deliver business workloads. Platform teams deliver reusable capabilities, enabling teams close skill gaps and help adoption. The platform doesn't approve work, it provides a paved road with guardrails that makes the safe thing the default thing, and the interface is the product. Self-service matters, templates matter, docs matter, APIs matter, because every manual interaction you require becomes a ticket later, and every ticket later becomes a bypass, so the platform team needs to ship in these forms. First, a subscription and environment creation pathway. Not an email, not a form, a mechanism. Ideally automated, management group placement, baseline tags, RBAC scaffolding, network attachment, logging baseline, and policy initiatives applied at creation. This is how you make time to first environment drop without hiring more humans. Second, a delivery baseline. Standard pipeline templates that teams can adopt with minimal changes, where variation is constrained but not outlawed. The platform team should provide the default scaffolding. Secure secrets handling, standard build and deploy stages, consistent artifact patterns, and guardrails that keep privileged execution from becoming an unmonitored attack surface. Third, shared observability, a logging and monitoring baseline that produces usable telemetry, not a pick-your-own-adventure of dashboards. If every team logs differently, you don't have observability. You have a distributed storytelling problem during incidents. Fourth, building blocks, standard modules that teams consume rather than fork. AVM and well-managed IAC modules are the antidote to Snowflake infrastructure, but only if you treat them like products, versioned, reviewed, documented, and upgraded on purpose. Now here's where most people mess up. They build the platform as a pile of controls, then they wonder why developers hate it. Controls without capability feel like punishment, and punished teams don't comply. They root around, so you need paved road adoption, not forced adherence. That means the platform must be faster than the alternatives. If the easiest way to get a compliant environment is to use the platform, teams will adopt it. If the easiest way is to copy a repo from a coworker and tweak it until it deploys, your platform will become irrelevant and your policy compliance rate will become fiction. And yes, this is measurable. You're not guessing. You measure time to first environment. You measure paved road adoption as a percentage of workloads. You measure exceptions and whether exception volume trends down over time. If exception volume trends up, your paved road is failing. The system is telling you that. Next, we'll look at the predictable failure mode. When you don't do this, the platform team becomes a ticket factory. Failure story A, the platform team became a ticket factory. This failure mode is boring. That's why it's so dangerous. It starts with good intent. A central platform team wants to protect the estate. Security wants fewer surprises. Networking wants fewer random VNets. Finance wants fewer mystery invoices. So the platform team becomes the choke point for anything that feels foundational. Subscriptions, network peering, firewall rules, identity integration, policy exemptions, pipeline approvals, even basic telemetry. Step 1 looks like control. It feels responsible. It even looks like maturity in an audit slide deck. Then adoption happens. A few early workloads land. People request new environments. A couple of teams show up every week, then every day. Suddenly you're running an enterprise cloud, and the platform team is still operating like it's onboarding 3 apps a quarter. So step 2 arrives quietly. Queues. The backlog fills with small asks that aren't actually small. Create a subscription, attach it to the hub, add RBAC, configure diagnostic settings, approve a service connection, add a private endpoint, exempt a policy for just this sprint. None of these are hard individually. Together they are a denial of service attack on your operating model. If you run a platform team, this is where reality turns cynical. The team's calendar becomes the product. The work becomes triage. The best engineers spend their week answering the same 5 questions in slightly different ways. And you start measuring throughput because it's the only thing you can influence. Tickets closed, average wait time, SLA compliance. That's not a platform strategy. That's survival. Step 3 is where the estate breaks. Teams root around you. They don't do it because they're malicious. They do it because delivery pressure doesn't care about your backlog. So they reuse an old subscription because it already exists. They deploy into a dev environment because it has network access. They copy someone else's pipeline because it worked once. They stash secrets wherever they can. They disable diagnostics because it blocks deployment. They avoid tagging because nobody enforced it at creation time. And the platform team is blamed for the drift that this behavior creates. That distinction matters. The platform team did not create the drift by being incompetent. The platform team created drift by being the only path. When you make the governed path slow, you force the organization to invent ungoverned paths. Now, the predictable reaction is the worst one. The platform team optimizes for ticket throughput. They create forms. They create approval boards. They create a ServiceNow taxonomy of cloud requests that nobody understands. They add a weekly architecture review meeting to reduce rework. They define a standard subscription request template that still takes 2 weeks because it depends on humans. The queue keeps growing, but now it's organized. This is what process maturity looks like when the operating model is failing. If you're a CIO, here's what to notice. You just built a central team that can't scale linearly with demand, and then you made the entire organization dependent on it. This doesn't fail by one dramatic outage. It fails by slow suffocation. Lead time climbs. Shadow, it grows. Policy compliance becomes performative because the real work moved outside the visible pathways. So what's the fix? The fix is not hire more platform engineers. That is how you pay for architectural erosion with headcount. The fix is to convert services into products and tickets into self-service pathways. Subscription creation becomes vending, not a request. If a product team needs a new environment, they should be able to get a governed subscription in minutes, with management group placement, baseline tags, RBAC scaffolding, network attachment, and policy initiatives applied automatically. Network integration becomes an interface, not a meeting. If workloads attach to HubSpoke or VWAN through a defined pattern, the platform team stops handcrafting peering and starts maintaining a standard topology. Pipelines become templates, not bespoke reviews. Teams can vary within defined boundaries, but they don't reinvent privileged execution from scratch. And exceptions become a first-class mechanism, tracked, reviewed, and expired. Not favors, not back channels. If exception volume trends up, that's a platform product signal. The paved road isn't good enough. Now, measure the new system like a product. Time to first environment becomes the primary KPI. Paved road adoption becomes the adoption metric. Exception volume becomes the entropy indicator. And policy compliance rate becomes the audit-ready scoreboard. That's the moment the ticket factory starts dying. Not because people tried harder, because the operating model stopped rewarding bypasses. The paved road, standardization that doesn't feel like punishment. So the paved road is the antidote to the ticket factory, but it's also where most organizations accidentally build a new kind of bureaucracy. A paved road is not standards. It is not a wiki. It is not a PDF called Cloud Guidelines V12 Final. It is a capability, a pre-approved path that is faster than improvisation and safer than creativity. That distinction matters. Most organizations try to standardize by telling teams what not to do. No public endpoints, no wildcard roles, no random VNets, no local pipeline hacks, and then they act confused when developers treat security like an obstacle course. Because you didn't ship a road, you shipped a list of potholes. A real paved road is opinionated. It gives defaults. It removes choices. And it does that for one reason. Cognitive load is the real tax at scale. Every additional decision a product team has to make is another place they can drift, another place they can invent, another place they can fork away from your intent. If you run a platform team, here's the rule. The paved road must be the path of least resistance. If the road is slower than the back roads, the organization will not learn. It will root around, always. And if you're a CIO, this is the implication. Paved roads are how you buy speed without buying chaos. They are also how you reduce audit scope without freezing delivery. You are not funding compliance. You are funding repeatability. Now, a quick clarification people confuse. Golden paths and paved roads are related but not identical. A golden path is a specific end-to-end workflow for a common scenario. New web service with standard logging, pipeline, and deployment, or new data workload with approved networking and diagnostics. A paved road is broader. It's the set of default routes and components that golden paths are built from. And both need escape hatches. Not because you're nice, because reality exists. The mistake that ruins everything is pretending escape hatches don't exist. They do. They're just undocumented, social, and inconsistent. That's what turns exception handling into entropy. So build the escape hatch. Make it explicit. Give it friction, but not shame. Now, what actually belongs on the paved road in Azure? First, subscription and environment creation that's already governed. Not request a subscription. Provision it, make it land in the right management group, apply baseline tags, apply baseline RBAC scaffolding, attach it to the network baseline, apply policy initiatives, turn on logging defaults. That's the starting line. Second, pipeline templates that constrain variation. Not one pipeline for every team. A small set of sanctioned templates, build, deploy infra. They should handle secrets correctly by default, treat pipelines as privileged execution, and provide consistent change evidence for audit. Third, IIC modules that teams consume, not clone. This is where AVM-style building blocks matter, not as marketing but as entropy control. Versioned modules with controlled upgrades beat 1,000 forks with silent drift. Fourth, observability defaults, diagnostic settings, activity logs, baseline metrics, and alerts. Teams can add more, but they can't opt out without an exception. If your logging baseline is optional, your incident response will be interpretive theater. Fifth, tagging defaults tied to cost ownership. This isn't pedantry. Tagging is how you map variable consumption to an accountable owner. Without it, showback is fiction and chargeback is political warfare. Now here's where orgs fail. They publish guidance, not capability. They create reference repos nobody uses. They create Terraform modules nobody trusts. They create a recommended logging pattern that breaks the first time someone deploys a service Microsoft added last week. And then they blame developers for not following the paved road. But developers don't adopt roads because you asked. They adopt roads because roads work. So build the road like a product. That means documentation that matches reality, versioning, deprecation, support boundaries, a feedback loop, and metrics, paved road adoption, time to first environment, exception volume trend, and compliance rate. And you need guardrails, not gates. Guardrails are fast feedback and enforced defaults. Gates are meetings. A deny policy that blocks obviously unsafe deployments can be a guardrail. A 3-week approval chain is a gate. One scales, one collapses. Finally, make exceptions visible. If a team needs to deviate, they should create an exception record that is reviewable, has a compensating control, and expires. That turns deviation from a secret into a managed risk. And once you do that, something else happens. You can see which parts of the paved road are failing, because exception volume clusters around friction. That's the system telling you what to fix next. Now, the road has to attach to governance somewhere real. In Azure, that attachment point is the landing zone. Azure Landing Zones, where org design becomes enforceable. Azure Landing Zones are where the paved road stops being a philosophy and becomes something Azure can actually enforce. Most people treat ALZ like a deployment artifact. Run the accelerator, get the management groups, policies, network scaffolding, and call it done. That is the shallow version. The real value is that ALZ turns your org chart into a control plane. It gives you a place to encode decision rights, so the platform behaves the same way on Tuesday afternoon as it does during an incident at 2 a.m. And this is the uncomfortable truth. Without a landing zone, your enterprise is not operating Azure. It is negotiating Azure. Every workload becomes a bespoke discussion about where it goes, how it connects, who can access it, and what compliance means today. That does not scale. It just accumulates. So think about ALZ in architectural terms. It is not an architecture diagram. It is a hierarchy and enforcement surface. Management groups become the policy inheritance tree. Subscriptions become the unit of delegation. Azure policy initiatives become the baseline assumptions you enforce at scale. And the network baseline becomes your blast radius boundary. Those 4 things are the levers that make autonomy with alignment real. If you're a CIO, this is the implication. ALZ is not a networking project. It's the control plane for delegation. It defines what the platform team can safely delegate to product teams without renegotiating security and compliance every sprint. If you treat it as infrastructure, you'll fund it once and then wonder why it rots. If you're a platform lead, ALZ is a product. Day 2 is the point. Version it, change it deliberately, measure adoption, track exception volume. Because the moment ALZ becomes a one-time deployment, it becomes stale documentation with ARM templates attached. Now, ALZ forces a split that many enterprises pretend doesn't exist: platform landing zones versus application landing zones. Platform landing zones are shared services and baselines, connectivity patterns, identity integration assumptions, logging and monitoring foundations, policy and governance posture. This is where you standardize once and stop paying the duplication tax. Application landing zones are where product teams live, workload subscriptions, environments, and resource deployments that produce business outcomes. The platform team should not be hand-editing those workloads. If they are, you didn't build a platform. You built an approvals team. The 8 ALZ design areas are useful here, but not as documentation theater. They are prompts for operating model decisions: billing and tenant design, identity and access, resource organization, network topology, security, management, governance, and platform automation and DevOps. Each design area is a place where you either codify intent or you leave a gap that becomes an exception later. And you can see why ALZ matters for the 3 headline metrics. Lead time drops when teams stop waiting for bespoke platform work and instead inherit working defaults. Time to first environment drops when subscriptions are created inside a pre-governed structure, not negotiated into existence. Policy compliance rate becomes measurable because policy is applied consistently through management group scope, not recommended in a wiki. Now here's the misuse pattern that kills it. ALZ treated as a starter kit. Teams deploy it, then they let project teams create subscriptions wherever they want, or they let networking drift into point-to-point peering exceptions, or they treat policy exemptions as permanent. Over time, the landing zone becomes a historical artifact that no longer reflects reality. And once that happens, the org stops trusting the platform and starts rebuilding its own pathways. So if you want the landing zone to stay real, you need one pressure point that never lies. Subscription creation, that's where delegation becomes enforceable. Because if you can control what happens at creation time, management group placement, baseline tags, RBAC scaffolding, network attachment, policy initiatives, logging defaults, you've stopped fighting drift after the fact. You've moved enforcement to the starting line. And that's where we go next: subscription vending, because autonomy isn't something you grant, it's something you engineer. Subscription vending, autonomy with guardrails in one mechanism. Subscription vending is where most enterprises accidentally confess they don't trust their own operating model. They say they want autonomy, but then a product team needs a subscription, and the process is open a ticket, wait, negotiate, and hope the platform team is in a generous mood. That isn't governance, that's a queue dressed up as control. Vending fixes that by moving control to the starting line. A good subscription vending flow gives product teams a governed, pre-wired place to deploy without asking permission for the basics. It's autonomy with guardrails expressed as a mechanism. Creation with enforcement, not provisioning with exceptions. If you're a CIO, here's the implication. Subscription vending is not an automation project. It's your delegation model made real. It's the difference between scaling by design and scaling by hiring. If you run a platform team, here's the uncomfortable truth. If you don't build vending, you will become the vending machine. Humans don't scale, APIs do. So what does vending actually mean in Azure terms? It means when a subscription is created, 4 things happen deterministically. First, it lands in the right place. Management group placement is not a suggestion, it's the inheritance model. If a subscription lands outside your hierarchy, you just created an ungoverned island. And islands become incident magnets. Second, it gets baseline identity and access scaffolding. Not everyone gets owner. You attach the right RBAC groups, enforce least privilege patterns, and make privileged access time-bound through your chosen process. You don't debate this per subscription, you apply it as a default. Third, it attaches to the network baseline. Whether you use hub and spoke or VWAN is an implementation choice. The operating model point is that workloads don't invent networking. They inherit it. Egress control, DNS patterns, private endpoint strategy, those are platform decisions that have to be consistent if you want a predictable blast radius. Fourth, it gets baseline governance, tags applied, policy initiatives assigned, logging defaults turned on. The point is that the subscription is born compliant enough to be safe, not compliant after the first audit finds it. Now, notice what's missing: a bespoke approval chain. Vending doesn't mean no approvals. It means approvals are scoped to deviations, not to existence. Teams shouldn't need a meeting to start work inside the paved road. They should only need a review when they want to leave it. This is where most people mess up. They build a vending process that still requires humans to approve every subscription every time because someone is afraid of sprawl. But the point of vending is to make sprawl governed. Sprawl is inevitable. The only question is whether it happens inside your control plane or outside it. And yes, the word sprawl is still the wrong diagnosis. The real failure mode is unmanaged creation. Vending makes creation managed. So how do you know your vending is working? You measure time to first environment. If it's minutes to hours, your platform is functioning. If it's days to weeks, you've built a ticket factory with better branding. You also measure paved road adoption at creation. What percentage of subscriptions are created through the vending path versus side channels? Side channels are where governance goes to die, and you measure exception volume, because exceptions should exist, but they should be visible, reviewed, and expired. If exceptions trend upward, your road is failing. Either the road is too narrow, or the guardrails are too strict, or the platform team is shipping policy without capability. Now, a quick warning for architects: don't confuse vending with a portal. The portal is an interface. Vending is enforcement. If a user can click a button and still create a subscription that bypasses network attachment, policy assignment, or tagging, then the portal is theater. The system will route around it the first time it's inconvenient. The win condition is simple. The fastest path to a usable Azure environment is also the most compliant path. And once you have that, the platform team stops being a bottleneck and starts being leverage. Now the starting line is solved. The ongoing problem is drift. And drift is where Azure policy stops being governance and becomes intent enforcement. Guardrails at scale, Azure policy, plus initiatives as intent enforcement. Vending gets you a governed starting line, but scale doesn't fail at the starting line. It fails 6 months later when the estate has changed hands 20 times, 3 teams rotated, and the original rules exist only in a slide deck that nobody opens. That is drift. And drift is what exposes the tooling lie. Because drift doesn't happen because you lacked a tool. Drift happens because your intent was never enforceable. And the platform did exactly what distributed systems do. It degraded toward the easiest local behavior. This is where Azure policy stops being governance theater and becomes what it actually is, an enforcement engine for assumptions. If you're a CIO, the implication is blunt. Policy is not documentation. Policy is the only scalable mechanism you have to make. We don't do that here true in the real system. It is audit evidence, it is risk reduction, and it is a cost control system when tagging and SKU constraints are part of the baseline. If you run a platform team, policy is also your escape from becoming the perpetual reviewer. If a human has to approve every safe decision, you designed a gate. Gates don't scale. Now, Azure policy by itself is a pile of knobs. Initiatives are how you turn it into something operable. An initiative is a bundled baseline, a curated set of definitions applied consistently at the right scope. It reduces the number of places you can get inconsistent. It also makes reporting sane because you're measuring 1 unit of intent instead of 50 independent opinions. That distinction matters because at enterprise scale, you don't lose control through missing policies. You lose control through inconsistent application of almost the same policies. Now, enforcement posture is where adults get separated from PowerPoint. Azure gives you effects like deny, modify, audit, deploy, if not exists. None of these are best. They are trade-offs in pain. Denies immediate control. It also breaks deployments, which means teams will either comply, or they will escalate, or they will route around. If you deny too early without a paved road, you just taught teams that governance is a blocker. Modify is the pragmatic compromise. The platform fixes the baseline for you. Tags get applied, settings get corrected. It's a guardrail that doesn't require a ticket. Audit is how most enterprises live forever. It creates dashboards, not outcomes. Audit tells you you're wrong. It doesn't stop you from staying wrong. Deploy if not exists is powerful, but it has operational consequences. Delays, remediation tasks, and eventual consistency that confuses teams when a resource looks fine, but becomes non-compliant later. That's not a reason to avoid it. That's a reason to design for it. Now here's the foundational mistake: treating policy exemptions as a one-time administrative action. Exemptions are not paperwork. They are entropy generators. Every exemption creates a parallel reality where your baseline is no longer deterministic. Over time, the estate becomes a collection of special cases, and your compliance rate becomes a polite fiction because the real system is the set of exemptions no one remembers. So you need an exception process that treats exemptions like radioactive material, controlled, labeled, and time-bound. Owner, reason, compensating control, expiration, review cadence. If it cannot expire, it is not an exemption. It is policy drift you are refusing to name. This is also why the compliance metric matters. Policy compliance rate isn't a vanity KPI. It's the externalized truth of whether your operating model still matches reality. And meantime to remediate non-compliance is the second half of the story. You're not measuring whether problems exist. You're measuring whether you can close them before they become incidents or audit findings. If you're a cloud architect, this is the hard lesson. Policy design without remediation design is just moralizing. Azure will happily tell you what's wrong. It won't fix your org's willingness to act. So keep it operational. Start with a baseline initiative that maps to your paved road assumptions. Allowed regions, required tags, diagnostics, network constraints, identity constraints. Keep the baseline small enough to enforce consistently, then expand it intentionally. And when you need to raise the enforcement posture, do it like an engineer, not like a crusade. Pick one control, provide the paved road, communicate the exception path, then flip from audit to modify or deny. That's how you keep guardrails from turning into gates. Next, we have to talk about the delivery system, because your pipelines are privileged execution. If you treat CI/CD like a hobby, governance will route around it. enterprise DevOps that scales beyond CI/CD as a hobby. Now we talk about the delivery system, because this is where organizations lie to themselves the hardest. They call it DevOps, but what they mean is we have pipelines. A pipeline is not DevOps. A pipeline is a delivery mechanism. And in enterprise Azure, delivery is a privileged execution surface that can change production faster than any human approval chain. That means your delivery system is part of your control plane, whether you treat it that way or not. If you're a CIO, this is the implication. The delivery system is your change control system. It is how you prove to auditors that changes are reviewed, repeatable, and attributable. If you don't design it explicitly, you will reintroduce manual governance to compensate, and you will destroy lead time to feel safe. If you run a platform team, this is where you usually fail by underestimating what you're shipping. You think you're shipping CI/CD templates. In reality, you're shipping a standardized way to execute privileged actions against Azure at scale across hundreds of teams. That distinction matters. Most enterprises start with local DevOps. Every team builds its own pipelines, its own Terraform workflow, its own secrets approach, its own environment naming, its own release choreography. It works until the first audit, the first breach investigation, or the first incident review where no one can answer a simple question: what changed, who approved it, and what did it touch? That's when the organization pivots into the wrong fix. Gates, CAB meetings, manual approvals for every deployment, security sign-off as a required checkbox, ticket-based service connection creation. It feels like maturity. It is not. It's a latency injection mechanism. The scalable model is different. Constrain variation, don't outlaw it. You standardize the high-risk parts and you allow local flexibility everywhere else. That means you ship a small set of pipeline templates that teams consume, and you make those templates the default interface for deploying infrastructure and applications. Teams can still choose their branching strategy. They can still choose their deployment cadence. They can still choose their service design, but they do not get to invent a new privileged execution model every sprint. If you're a cloud architect, focus on the invariant. Pipelines run identities. Identities have permissions. Permissions shape blast radius. So if your pipelines can run arbitrary scripts with broad credentials, you didn't build a delivery system. You built a distributed admin console. The practical control points are boring, which is why they get skipped. First, standard pipeline templates with guardrails. The template should encode minimum evidence: what artifact was deployed, from what commit, by whom, with what approvals, into what environment. That is not bureaucracy, that is traceability. Second, treat secrets and access like production dependencies. Use a real secret store and stop pretending variables in a pipeline UI are good enough. The system will route secrets into logs, into outputs, into human screenshots. That's what systems do. Your job is to reduce the probability surface. Third, constrain infrastructure changes with reproducibility. If environments aren't reproducible, you will rebuild them under incident pressure, and you will introduce drift while trying to reduce it. Infrastructure as code isn't a nice-to-have at scale. It is the only way to make environments less personal. Fourth, GitOps patterns where they fit. Not as a religion, but as a way to make desired state explicit and reviewable. If the running state is the only truth, you can't govern it. You can only discover it after it hurts you. And then there's the part people don't like hearing. Startup freedom doesn't survive enterprise audits. In a startup, you can accept informal process because the org can still hold the whole system in its head. In an enterprise, you can't. You have too many teams, too many changes, too many dependencies, and too much turnover. So the delivery system must be standardized enough that new teams can ship safely without becoming experts in your organizational history. That's the entire point of a paved road. Now, what does success look like in your 3 headline metrics? Lead time drops when teams stop reinventing pipelines and stop waiting on bespoke approvals. Time to first environment drops when the delivery system integrates with subscription vending and the baseline pipeline can deploy into a governed subscription immediately. Policy compliance rate improves when the delivery system stops being an escape hatch and becomes a consistent enforcement surface. Templates apply tags, enable diagnostics, and deploy modules that already conform to policy baselines. Once you nail this, everything else clicks, because repeatable delivery requires repeatable building blocks, and that means modules, not forks. AVM plus ISE, repeatability as default, not a side project. Once you accept that the delivery system is a control plane, the next uncomfortable truth shows up. Repeatability is not a preference. It is the only way an enterprise survives its own turnover. Most organizations treat infrastructure as code like a tool choice. Terraform versus Bicep, pipelines versus scripts, repo structure arguments that never end. But the actual problem isn't syntax. The problem is variance. Every bespoke module, every copied repo, every temporary tweak becomes a snowflake you will own forever, whether you intended to or not. And at Azure scale, snowflakes don't melt, they multiply. If you're a CIO, here's the implication. Every forked infrastructure pattern is future operating cost, not because it's morally wrong, Because it's a different failure mode your teams must remember during incidents and audits. The organization pays for that in lead time, rework, and human fatigue. If you run a platform team, this is where you usually lose credibility. You publish a reference module, but it's incomplete, undocumented, and breaks the moment a real workload hits it. So teams do what teams do. They copy it, they patch it locally, and now you have 5 forks with 5 security postures. Congratulations, you just invented distributed platform engineering. The alternative is to treat modules as products. This is where AVM, Azure Verified Modules, maps cleanly to operating model intent, not as a badge, as a discipline, standardized building blocks that teams consume, version, and upgrade deliberately. AVM matters because it pushes you toward a default behavior, reuse instead of reinvention. That distinction matters because ISE without module discipline just moves drift from the portal to Git. Now, there's modules as products has a few non-negotiable properties. Versioning. If a module doesn't have controlled versions, you can't reason about change impact. You can't coordinate upgrades. You can't audit what's deployed. You're just hoping. Documentation, not a marketing page. Real usage guidance, inputs, outputs, and constraints. If the module requires tribal knowledge to use safely, it's not a module, it's an entropy generator. Testing and review. Infrastructure is code, therefore it needs the same discipline. Review gates that are fast, deterministic, and visible. Guardrails, not committee meetings. And finally, upgrades as a managed process. You don't customize the module to fit your workload, because the moment you do that, you didn't customize. You forked, and a fork is a permanent liability with a friendly name. If you're an architect, this is one of those system laws. The first fork feels like agility. The 20th fork becomes an audit event. So you need a pattern that keeps teams inside the paved road while still letting them ship. A simple model is platform team owns the module backlog and the release cadence. Product teams consume modules and can request features through normal backlog intake. If a product team needs something truly unique, that becomes an exception pathway decision, not an ad hoc commit, and you measure it. Paved road adoption isn't just did they use the pipeline, it's did they deploy from sanctioned modules or did they fork their own reality. Module adoption is measurable, fork count is measurable, upgrade lag is measurable. Now bring this back to the 3 headline metrics. Lead time improves when teams stop inventing infrastructure patterns in every project. They assemble workloads from known building blocks. Time to first environment improves when environment scaffolding is a reusable composition, not a bespoke engagement. You can't self-serve environments if every environment is handcrafted. Policy compliance rate improves when modules already embed the controls you intend to enforce. Tagging, diagnostics configuration, networking patterns, secure defaults, policy then becomes validation, not constant conflict. And yes, there's a cost. You are trading some local flexibility for global predictability. That's the trade you want. Because Azure at scale is not about how fast you can build the first environment. It's about whether the 100th environment looks like the first one without needing the same humans to remember how it was done. Next, we talk about the layer that makes every incident either solvable or theatrical: shared observability. Observability as a shared service, not a team preference. Observability is where the enterprise finds out whether it built a platform or just funded a collection of opinions. Most organizations treat logging and monitoring as a team preference. One team loves application insights, another team ships custom dashboards, another team logs to whatever the vendor recommends, and a fourth team forgets diagnostics entirely because nobody blocked the deployment. That isn't observability, it's a distributed narrative system. And during an incident, narratives don't restore service. If you're a CIO, here's the implication. Inconsistent telemetry turns every outage into a people problem. Not because engineers are bad, but because you force them to reconstruct reality from incompatible signals while customers wait. That is operational risk created by governance drift, not by technical incompetence. If you run a platform team, this is where you usually lose trust. You can't demand SLO ownership from product teams while giving them a monitoring foundation that's optional, fragmented, and priced like a surprise. So the reframe is simple. Observability is a shared service, like identity, like networking, like policy enforcement. Teams can build on it, but they don't get to reinvent it. There are 2 reasons this works. First, it creates a consistent incident language. When every workload emits baseline telemetry in a consistent way, you can write runbooks that apply across teams. You can train on-call engineers without teaching 10 custom logging schemes. You can correlate across subscriptions without archaeology. Second, it creates evidence. Audits don't care about your intentions. They care about records. What happened, when, who changed what, and whether you can show control in the real system. Azure gives you the raw ingredients for this. Azure Monitor, log analytics workspaces, diagnostic settings, and activity logs. But the platform won't decide your strategy. You will. The foundational decision is workspace strategy. Centralized versus segmented isn't theology. It's an access and accountability decision. A central workspace can simplify cross-team investigation and correlation. Segmented workspaces can align to data access boundaries and compliance requirements. Either can work. What doesn't work is accidental sprawl. Dozens of workspaces created per project because that's what the portal wizard did, and then nobody knows where the logs went. So pick a model, publish it, and make it the default through the paved road, and then enforce the baseline telemetry. This is where most people miss the mechanics. You don't get a baseline by asking nicely. You get a baseline by making it the default outcome of deployment. For Azure resources, that means diagnostic settings get configured as a standard, not negotiated per team. Activity logs get routed where your incident responders can actually query them. Critical categories get collected consistently, so security and operations aren't guessing which table to search during pressure. If you're an architect, notice the pattern. This is identical to policy and networking. The default has to be enforceable, otherwise the system drifts. Now define your operational metric correctly. MTTR is not enough because MTTR collapses multiple failures into one number and it hides the real issue. You spent half the incident just figuring out what was happening. So track mean time to detect and mean time to explain. Mean time to detect tells you whether your signals are fast and reliable. Mean time to explain tells you whether your telemetry is usable. You can fix a system you understand. You can't fix a system you can't describe. And this is why team preference breaks at scale. Preferences optimize locally, shared services optimize globally. Now the cynical truth. Observability becomes the first budget fight. Logging costs money, retention costs money, centralization costs money. And if you don't design the cost model, teams will do what they always do. They'll reduce logging to reduce spend, and then they'll act surprised when incidents take longer. So link observability to accountability. And if you want showback and unit economics to be real, you need consistent tagging and cost ownership, but you also need consistent telemetry so you can tie cost to behavior, noisy logs, high cardinality metrics, runaway ingestion, unbounded retention. Those are architectural outcomes. They shouldn't be invisible. If you're a CIO, this is where governance stops being security and becomes business control. You're funding a capability that makes outages shorter, audits easier, and cost arguments factual instead of political. And if you run a platform team, this is how you prove value without becoming a ticket queue. Ship the logging baseline, measure coverage, measure time to detect, and show the exception trend. Because the moment teams can opt out, they will. Not out of malice, out of pressure. Next, we talk about the other shared service that defines blast radius, whether you admit it or not. The network baseline. Network baselines hub and spoke thinking beyond wiring. Networking is where the enterprise discovers whether it believes in blast radius. Because identity is who can do things, policy is what is allowed, observability is what you can prove, but the network is where failures travel. And most organizations treat it like wiring, as if it's just connect the thing to the thing, then move on. That is not what it is. In an enterprise Azure estate, the network baseline is a security boundary, an operability boundary, and a cost boundary. It defines what can talk to what, where traffic can exit, how private services are consumed, and how lateral movement happens when something goes wrong. That distinction matters because breaches and outages don't spread through org charts. They spread through routes. If you're a CIO, here's the implication. Networking is not a product selection debate. It is an operating model boundary. It decides which responsibilities live with the platform team and which responsibilities are delegated to product teams. If you get that boundary wrong, you don't just get bad architecture, you get permanent exception pathways that become untouchable. If you run a platform team, here's the uncomfortable truth. Every just this once network exception becomes a future incident you can't debug at 2 a.m. because nobody remembers why it exists. Point-to-point peering, ad hoc firewall rules, one-off DNS hacks, these aren't misconfigurations, they're design omissions that became permanent. So what does a baseline actually mean? It means you pick a shared services pattern, hub and spoke, or VWAN, or whatever your chosen reality is, and then you treat it like a platform product. A hub is where you centralize capabilities that should not be reinvented per workload. Firewalling, egress control, DNS strategy, private endpoint patterns, shared ingress, jump access, and network observability. Spokes are where workloads live, inside constraints with predictable routing. And the point is not the diagram. The point is that the hub is the place where the platform team can enforce assumptions, and the spokes are the place where product teams can move fast without inventing their own perimeter. If you want autonomy with alignment, this is one of the most honest mechanisms you have. Now, here's where most people mess up. They confuse centralization with control. They centralize everything, then they make every change a ticket. Please add this firewall rule. Please peer this VNet. Please create this private DNS zone. Please whitelist this IP. And then they act surprised when teams bypass the network baseline by deploying public endpoints, or by creating alternative routing, or by spinning up temporary connectivity that becomes production. The network baseline cannot be a help desk. It has to be an interface. In practice, that means the platform team owns the connectivity substrate and product teams attach to it through a deterministic pattern, not through a meeting, not through a Slack thread. If you remember nothing else, the network baseline is how you control blast radius without controlling every deployment. Now connect this back to ALZ and Vending, because this is where the system actually becomes enforceable. At subscription creation time, you can attach a subscription to the network baseline, place it in the right management group, apply the policy initiative that enforces network standards, and ensure the default route and DNS patterns match the platform posture. This is what prevents the first workload from inventing its own perimeter, and it also prevents the platform team from being dragged into every spoke as a human router. From there, product teams can still own their own spoke VNet, their subnets, their NSGs, and their application-level connectivity decisions within the guardrails. They can still ship, but they don't get to define enterprise egress policy. They don't get to define the organization's private endpoint strategy. They don't get to decide that DNS is optional. Those are platform decisions because they affect every other team's ability to operate safely. And the failure mode is predictable when you don't do this. The hub becomes mostly standard, and then it accretes exceptions. Direct peering because someone needed lower latency, special routes because a vendor required it, temporary public access because private endpoints were too hard, and DNS changes because nobody wanted to align workspace boundaries with network boundaries. Over time, the baseline stops being a baseline. It becomes an archaeological site. So treat network exceptions like any other exception: owner, reason, compensating control, expiration. If you can't expire it, make it the new baseline and update the platform product. Because unmanaged network exceptions don't just create drift, they create invisible pathways. And invisible pathways are how both attackers and outages move laterally. Next, scale turns into money, and money is the one control system nobody can ignore. Financial and operational accountability, FinOps as a control system. Now scale turns into money, and money is the one control system nobody can ignore. Most enterprises treat cost as an after-the-fact report. You spend first, then finance shows up later with a chart and everyone argues about why it happened. That's not FinOps, that's archaeology. FinOps is a control system. It's how you keep variable consumption tied to an accountable owner in near real time with a feedback loop that forces trade-offs into daylight. Without that loop, cloud cost doesn't get managed. It just gets redistributed into politics. If you're a CIO, this is the implication. The cloud is a variable cost engine. If you don't build a variable cost operating model, you will default back to capital-style governance, committees, quotas, and blunt denial. That protects the budget while it destroys lead time and innovation. If you run a platform team, this is where you usually get blamed for bills you didn't approve. And if you run product teams, this is where you discover the difference between shipping and owning. Because in Azure, every deployment is also a financial decision. Start with the truth nobody wants. Tags are not a naming convention. Tags are the cost ownership map. If a subscription or workload cannot be mapped to a cost owner and an environment, you cannot do showback. You can only do blame. So the first FinOps control is boring. Enforce tagging at creation, not later, not with a quarterly cleanup sprint. At creation, through your vending path and policy baseline. If you can't do that, you don't have cost governance. You have a spreadsheet habit. Then you graduate in stages because chargeback too early creates rebellion. Stage 1 is showback, transparent reporting that makes costs visible by owner, team, and environment. It changes behavior because it makes consumption legible. It also exposes the shared services problem, the hub, the firewall, the logging workspace, the platform subscriptions. Those costs are real and they need a model or they will be treated as someone else's overhead forever. Stage 2 is accountability, budgets, alerts, and anomaly detection per owner. Not to punish teams, but to force timely decisions. This is where cost becomes operational. Why did ingestion spike? Why did egress jump? Why did this environment never shut down? Why is this SKU used here? These aren't finance questions. They're architecture questions with a price tag. Stage 3, when culture can handle it, is chargeback. Teams pay for what they consume, and shared services have an explicit pricing model. This is where the organization stops pretending cloud spend is centrally controllable while remaining decentralized in delivery. It isn't. If teams deploy, teams must own. Now connect this to the operating model mechanics we've already built. Subscription vending gives you the place to attach cost ownership at the start. Tags, cost center, product identifiers, environment. Azure policy initiatives give you enforcement. Require tags, modify missing tags, audit the rest. The paved road gives you the default patterns that avoid expensive improvisation. And the delivery system gives you traceability, which pipeline deployed what, into which environment, with whose approval. If you're an architect, this is the uncomfortable truth. Cost is a reliability signal. Unbounded logging is cost. Over-provisioned networking is cost. Idle environments are cost. These are also operational failures because they indicate you don't control lifecycle. So use unit economics, not just monthly totals. Pick one unit metric that makes sense in your world. Cost per environment, cost per product team, or cost per deploy. Then track it over time. If unit cost rises while delivery slows, you're not scaling. You're accumulating entropy with a larger invoice. And tie it back to the 3 headline metrics, because this is where leaders can't hide. Lead time improves when teams aren't blocked by ad hoc budget panics and late-stage procurement debates. Time to first environment improves when environments are created through vending with predictable cost tags and baseline controls, not negotiated through finance. Policy compliance rate improves when governance includes cost controls that are enforceable, not aspirational, required tags, allowed SKUs where it matters, and diagnostics defaults that prevent turn it off to save money from becoming a silent outage tax. FinOps isn't cost-cutting, it's truth maintenance. And when truth becomes continuous, the operating model stops relying on trust and starts relying on signals. Long-term success, operating model as a living system. Here's the part leaders avoid. The operating model is never implemented, it's maintained. Drift is the default, so enforcement is the job, and enforcement requires a cadence. Quarterly, review 3 signals: lead time, time to first environment, and policy compliance. Then look at the entropy indicators behind them: paved road adoption, exception volume, and mean time to remediate non-compliance. If exceptions rise, the road is failing. If remediation lags, governance is theater. If lead time rises, you rebuild gates. Treat the platform like a product. Version changes, deprecations, and clear interfaces. And write decision rights down, because turnover is guaranteed and memory is not. Closing reflection plus 7-day action. Azure at scale is leadership design, not technical assembly. In the next 7 days, run a 90-minute workshop with platform, security, networking, and 2 to 3 product teams. Output 3 artifacts: a decision rights matrix, a paved road MVP backlog, 3 to 5 golden paths, and an exception pathway with owner, compensating control, and expiration. If you can't print those 3 things, you don't have an operating model. You have intent. Subscribe and watch the next episode on cost governance and platform maturity.